So we did have some questions submitted through the Google form, so we will be talking about them. They're very general questions, but if you have your own questions, feel free to open your mic and talk, or you could type it in the chat and one of us will ask it for you. And yeah.
Okay, so without further ado, we're going to move on to our first question. This question is going to be directed generally to all the professors. So our first question is, what kind of careers outside of academia could one consider in environmental science, biology, physics, or chemistry? Like what kind of jobs that you can get into with a degree in any of these departments? If any of the profs wants to take that first question.
I'd be okay to tell you a couple of things you may not have thought about for physics. One of my former PhD students is the head of medical imaging at the University of Manchester in England. And even though he did a PhD with me in geophysics, he learned so many tools for visualizing large data sets, particularly on supercomputers and from computational fluid dynamics, that he had all the skills necessary to start doing all the imaging visualization for things like MRIs and CAT scans and other parts of radiology. And he's of a physics background. I guess one other thing I could mention, because I know often people are doing or have aspirations to get into medicine, and then have said to me, I don't know why I need to do physics if I want to go into medicine, to which the answer is, well, I guess you don't want to do anything in radiology or ever be able to read an X-ray or understand anything about, you know, to do endoscopy or any of these sorts of vital areas, or, you know, so there's lots of applications, in other words, for just having a technical background of someone who's studied physics. And even a lot of other people who do physics, not that I would encourage you to do this, but they go into banking, you know, so there's a lot of opportunities just because of the sort of the mathematical modeling that you can, the skill set that you pick up from physics, and the fact that you have some similar sorts of equations that govern economics to things like govern the flow of heat through a metal, you know, diffusivity and dispersion and these sorts of things. Then there's also applications for environmental physics, like using geophysical equipment, the assessment of hazards, so seismology, using equipment to understand magnetic fields if you want to get into things like mining, and all kinds of things to do with natural resources and to do with cleaning up the environment and looking at issues. One other quick thing I'll tell you about was I took a lot of students, this is back when I worked in England. We went over to Portugal, and the thing we did for a little while in the summer as part of a field school was to map out the water that was flowing through a graveyard. And the reason they were interested in this was because the graveyard was sort of all put in place in the early 1800s. And they came to recognize that all of those old coffins were lined with lead, and there was dangerous lead leaching out into the water table, and they wanted to map the water flow direction before all of that nasty chemistry got into the local water supply. So that probably opens the door for one of the chemistry profs to tell you what opportunities exist.
Just want to double down on the finance and banking. That's probably, it's not necessarily because equations are the same, but maybe a lot of programming skills are required, and in general, working with hard things, which is like, if you go to grad school, and I probably strongly advise you not for the purpose of finding a job which is related exactly to expertise, but like as life experience, it completely changes your way approaching any kind of problem. And a lot of people after masters or PhD will go somewhere else. but it really changes your perspective on things. And well, I can say mentioning programming now as a new type of things is machine learning, which is also, well, useful in finance as well, but probably in a lot of various startups that are around. And Toronto is famous for very active startups in chemistry, in physics and materials, in anything where you can apply different skills from that you are acquiring right now.
I will definitely admit, sorry.
Go ahead.
I'll definitely admit I was one of those students that thought last semester, why do I need to take physics? Because I never want to be a physicist. And I think a lot of us now, with programs coming up, we've realized looking at the required courses that physics is everywhere. It's actually everywhere. Whether that's like you say this with disdain or you say this with a smile, it's everywhere. So go ahead, Professor Sturge.
Yeah, I was going to say, it really depends on how much education you finish. If you stop at the undergrad level, I would say you could pretty much go anywhere you want that doesn't require higher levels of education. Like a lot of the people I went to undergrad with, some work as law clerks, some work in insurance, some work at banks, they kind of went everywhere. Even some that got biology degrees, for example, now work in administrative work at universities. So for example, some of them are course coordinators now, which does require understanding the course, but doesn't necessarily require teaching. So they're more organizational behind the scenes. A lot of the students that I went to grad school with, one of them's a political lobbyist now. So he plays a role in DC, basically explaining science to politicians. One of my friends got an undergrad in chemistry. She now works at Laurier. So she helps develop makeup and shampoos and things like that. So it really depends on where you want to go. Two friends work at collections at museums. So they're the collections managers now. And then one friend works at a zoo. So really, I think the further you go in education, the more you kind of figure out what you're interested in, and that will kind of direct your career path.
I'll mention a couple of unconventional chemistry pathways that some of my TAs have chosen. It's very interesting. So I'm currently working with her on a project, and she has done her degree, PhD in chemical education. And because of the online situation, now she's working on a project on developing simulations for chemistry courses as an educator. So that's, again, combining chemistry degree with perhaps, computer science or computational chemistry will be a great idea. And there is another student and also a graduate from UTSC. She has done her undergraduate degree in chemistry, and now she is our illustrator for first year resource package that the three of us are working for. So again, combining chemistry with art, but with the chemistry background, she's able to make these illustrations. A colleague of mine, while I was doing my PhD, he went down the route of becoming a forensic scientist after doing a chemistry degree. So again, if you think out of the box in a creative way, in an interdisciplinary way, you can come up with careers that are more creative and also to solve real life problems. So these are my suggestions.
I'll add a little bit to what Nirusha just said. When I was a grad student, I mentioned this in other forums. One of my fellow grad students went to Ottawa, and they're now a patent, not a patent lawyer, but they work in the patent law office. And so they read through patents and, give recommendations on their acceptance or modifications because they know the science, but they also have a little bit of a law background. So that's another unconventional route, maybe, that you might not think of a chemist going to. We have had graduates going into food chemistry. I mean, that's kind of a given. So you can do food chemistry. I think she works at Ferrero Rocher. So the chocolate factory, or the chocolates that have the little hazelnut inside. So she's like a food quality, I guess, lab tech over there. You can go into cosmetics, obviously the usual routes of, lab technicians, lab managers, startups, hospital research. Those are the more conventional methods. Right now, I think in another forum, one of my colleagues, Dr. Sauer, mentioned you can go into scientific communication. So right now, with COVID and everything, and so much science being in the news, trying to, you know, teach the science and communicate the science to the regular population, the general population. So scientific communication is a big area that you could go into with a science background, be physics or biology or chemistry. So there's some of the other unconventional routes that you could think of.
Yeah, for sure. I feel like ever since COVID started, there's this more awareness for science globally. I remember like having discussions with my parents about science stuff that like I would never talk about before, but being in a science program and having, you know, a worldwide pandemic, it's kind of fitting because it's like I'm learning about it in class, but I'm also learning about it in the news. And it's really like brings a bridge towards that the science that we learn in school, like there's a future to it. And like I feel like a lot of people who go into STEM fields, there's a discouragement, but in reality there's a lot of opportunities. And yeah, and it's especially like in a pandemic, students may not know all those opportunities, so yeah, we really appreciate. So my next question is directed towards Professor Tavaraja. So in the pandemic, it's been really hard for first years to get that first year experience in terms of asking about research opportunities or, you know, doing lab volunteering. So in your opinion, like how does a first year go about getting a research opportunity, especially during this complicated time, and especially when it's kind of hard to make connections with professors and, you know, work in a lab?
Yeah, it's very challenging times. I mean, when it came to like, as Professor Dalili mentioned, PSEB 90 is a course that you should consider taking to fulfill the gap of not having the skill development in first year chemistry labs, because yeah, we did not do any hands-on work. We're working on simulations. Definitely it cannot replace the real life experience. So the hope is that, you know, there is a way for us to give these skills through, you know, voluntary experience or through the PSEB 90 course. One thing that we can do, I don't know how things are going to go for the summer, is that there were students who reached out to me and also to other professors to work on pedagogical developments. Yeah, it's not, you know, in lab work, but they wanted to work on, for example, question bank development, or just to gain that knowledge, just to keep in touch, just to have some sort of a connection with faculty and their peers throughout the summer. So things like that you can do for the current time, but hopefully things turn out to be better. I don't know how it's going to be, but if we can be back on campus over the summer, then I would consider, you know, PSEB 90, reaching out to faculty for volunteer opportunities, etc., to fill in that gap. Did that help at all?
Yes, thank you. And if any professor wants to add on to that, you can go ahead.
Yeah, I can add. So definitely B90 and Chem D90 are great courses. I would say maybe don't rush to do it in the first year. So get acquainted with profs. So really like talk to the profs that you already like and like try to get in touch. And actually we do have space in the lab right now, even though the teaching labs are not easily available. The research lab are actually open and functioning, and you could potentially, well, it depends how busy you are, but potentially you can get some access to the labs. But again, it's better to have some experience. It's better to show what you know. It's even better if the prof already knows you and you know the prof. But other than that, well, talk to people who already did it. So I don't want to put Sepper on the spot, but he did this in the first or second year. So maybe Sepper, you could share your experience.
Let me turn on my camera first. Yeah. One of the best experiences I had that summer working with Professor Vosny. But doing research is different from doing taking a course in a way that you're focusing on one specific problem, and there's usually no right or wrong answer. You just have to you have to focus hard on that single problem. And there's a lot to learn.
So yeah, it's definitely something. Well, research is definitely different from learning, and well, we've tried working with students in the first year, and they just come and they get lost very easily. So yeah, you probably need a little bit more experience to start doing research. I'm happy that you know that maybe you want to go to grad school, so it's really important to do some research. It's super important to do research before you graduate, but you kind of have enough time to do that in a later year. So definitely B90 and D90 are good courses to start with.
Thank you, Professor Vosny, for that. We know that as first years, we have some talents and we lack in other areas. So again, at least something to look forward to for the future. We are going to go into break. Sorry.
Yeah, so I just want to say one more thing. So I've been talking to other universities, and they have an amazing course, which really should discuss this in the department somehow, how to organize it. But it's like a research course for undergraduates. It's mostly about how to do literature research, about seminars, doing presentations, and like, well, I don't know, give you an idea of research. And that's not what we have. We have something like that for grad students, but other universities have this at the undergraduate level. And I thought that was really interesting and could be useful. So in ChemA 11 and 10, we're trying to introduce this kind of writing a research article, which is short, but really going through peer review process. I think that's a good start, but there is definitely so much more to try and to learn about what is research and how it's different from learning.
And also, like when the PSCB 90 rolled out, that was sort of like the objective behind it is to actually do some sort of an, in lab undergraduate research experience, not to an intense level, but at least to get them hands-on in terms of some, some of the labs that are available in the literature. We did that one term, and then the pandemic rolled out. We couldn't do anything in person. So that's something to consider definitely when we go back.
I'm just afraid that doing like a real lab research in the first year or even in the second year can you discourage you more than it can teach you. So like it should be really, well, if you went through it and you are still fine with that, maybe that's good, and like you really know that you want to go to research, but it's not what you expect, I would say.
Sorry, so real quick, I see Professor Lohman, you have your hand up.
I do, yeah. I was going to mention that, well, first of all, I agree that if you're in first year, you shouldn't put a great deal of emphasis on trying to get a research position at the end of that year, because you have to realize that most of those positions you are in competition with second and third year students, and obviously they know more than you. You're going to hope by the time you're in third year that you'll know more than the first year students and aren't, being swept aside for somebody who just came in and has 1 year of experience under their belt. So in general, don't put pressure on yourself to find some sort of a summer position after your first year. That doesn't mean it's impossible, though. I actually did take a first year student last summer, and he had quite a successful summer with me. It wasn't, it was a little bit more of a struggle, I think, than it was for older students. But also, if I don't put him on the spot too much, I see that I have a current undergraduate research assistant who's attending this meeting, so he knows I'm about to pick on him. And maybe he could talk a little bit about his experience, because he started working with me last summer and is still working with me as a part-time assistant now. So it's Pejvak, Java Harry. And Pejvak, you want to maybe talk a little bit about your experience and how you went about finding a position?
Sure. Hi. By the way, I wasn't able to actually introduce myself. I'm the physics director. But at EPSA, I'm a third year. And yes, I had the great opportunity to first be at the CPS summer research the internship as a whole, and it was a great experience. I think one of the things that really helped me from the, let's say, first year courses that I've taken was actually computer science courses. I think especially now, I think math, at least for, let's say, computational subjects, math and computer sciences are really, let's say, quite high. So in terms of importance. So I think if I were in my first year, I would have taken another computer science related courses, or in my second year. So I think it's really important to have a base knowledge to actually be able to then build on that and get different experiences. So I mean, it's 21st century, so it just makes only sense to have some computer science knowledge in that. Yeah, but in general, it was a great experience. And then also just a last minute thing, make sure to like read all the announcements, because most of the time there are many different announcements there posting like different opportunities, and even sometimes I've heard no one even applies. So it's just give it a try. Yeah, that's a quick wrap up.
I'd just like to add another thing to that. We do have some opportunities that are coming up that will be announced in the next 3 or 4 weeks for some summer intern positions. This is for a new center that is under the umbrella of the Department of Physical and Environmental Sciences, and the announcement will come under the Center for Research in Earth System Science. And there are positions there for physics and geology, and also some environmental and possibly a couple of other areas as well. So you should, as Pejvac just said, you should look out for these, because last year we had 4 paid positions and there were not a great deal of applicants. And that's how, you know, it came to looking at first year students. So keep your eyes open for any announcements. And one other thing that Pejvac said was about the computing. For anybody who's doing physics or environmental physics or physics and astrophysics, there is a second year numerical methods course, which I believe is an option for environmental physics. I would suggest that you strongly consider taking that second year course. And you can ask me a question by sending me an email if you want to know more about that.
So sorry to cut you off, Professor. That was amazing to share the opportunity. But since Professor Bayer is about to leave really quickly, we do have a question in the chat from Feiyu. So the question is, I was wondering if it's possible for Professor Bayer to share some advice for students who want to pursue graduate studies in astronomy and /or astrophysics.
I will have to leave that to Julian, because I cannot give an answer to that question without probing some more back and have an actual dialogue about that. That's actually more open question than something that I can say in just 2 minutes. So I will leave that one for Julian, if Julian is joining the breakout rooms, to talk about that specifically. So sorry, but that's not something that I would be comfortable in just giving 2-minute answer, because I would like to actually engage in the dialogue as to what it means, and then therefore what it would be good for doing so.
If anything, you can just email Professor Bayer. I'm sure he would be more than happy to answer your question, I hope. Is that fine, Professor Bayer?
Yes, absolutely. I believe most of you are currently in the thermal physics course. And if you are not, then it doesn't matter. So yes, do please email me if you want to continue that discussion.
If anyone joining us today wants to email any of the professors for any further questions and you can't find their information, you can always go through us as well. Reach out to EPSA and we can help you connect with those professors. In terms of the breakout rooms, we are going to start them now for any further questions. We're going to manually make some of the changes to the room. So you should be able to join any of the rooms you want. Just not quite yet. We are actually going to combine physics and environmental science just because some of the professors are leaving. So if anyone invited in physics could also just join environmental science instead. So the room that says bio/environmental science will actually be for physics as well. So please join that room instead if you're looking for physics as well. So anyone interested in chemistry, please join the chemistry breakout rooms. And then anyone interested in environmental science, biology, or physics, please join the room that's called biology and environmental science.
And if midway through the discussion you want to kind of rotate or move to a different room, you can always raise your hand or just move out from your respective breakout rooms to the
They
ones
will
that you
be
want.
ending at 7:15, so you can come back or we'll bring you back. But we will be hopping through the breakout rooms and we'll be seeing how the things flow.
Oh, and if you need help moving into the breakout rooms, do let us know.
Yes.
Okay, I should mention we have quite a few in the physics just for
I know.
our three MCs here. So
I'm moving them.
I think
I'm moving them slowly.
I think the bio is supposed to be here. I don't know.
okay, so I'm gonna let them know that they should join.
Yeah. Okay, good.
Hey, profs, how's it going?
Hey,
Good.
Michael, how are you?
I'm having a
Where are
great
you
time.
now?
I'm having a great time.
What year are you in? Is it fourth now?
Oh, yeah. I am getting older. But,
Hello, Professor Vosny. How are you?
Hey guys.
how y'all doing? How is the semester for y'all? I know I talked to Nusha about that, but how are you, Fosni? How's it going for you? How is using the A level, right?
It's been busy because students' expectations were different this semester, so we had to record a lot of lectures, and I didn't have pre-recorded them, so I had to do it on the fly. And it's not like a lecture you can do it last minute. You actually have to do it 2 days in advance. So, and I'm always late, so I'm almost doing the last day, and people complain about it. But yeah, I don't know. I want to hear from you guys. Seems like people like it more because if you know, A11 is like the worst course in terms of student evaluations.
Oh no. That's very scary, but okay.
So I don't know how it goes this year, but I think it's okay. So I'm happy it's gonna be over soon. And I really needed this reading week break.
Yeah. Also, as a student from A11, we really do appreciate all of the recorded lectures and the slides. And
I don't know, I'm not doing anything special compared to last year, but I had so much different feedbacks this year.
Oh no. Yeah. I also think like since it's e-learning, it's hard for like everyone to try and adapt. So
I can tell you that B21, so A11 goes so much better than last year, and B21 goes so much worse because I don't know, it's probably much more in person. It's more complicated course, so I need to feel this connection to students, to see them, to talk to them, and they're just not talking on Zoom. So I don't know how to do it.
Yeah. And also I think because with the recorded lectures, like students don't feel the need to like maybe talk in the live ones too. So maybe it's so I did want to ask about chemistry, like in terms of labs. I know a few upper years they talk about lab like volunteer opportunities and stuff. And I was just wondering, we talked about it briefly in like the main room too, but because we as first years are doing labs in all virtually through Labster, which is a great experience, but obviously like the trial and error, especially professor was talking about titrations during our class, and it was like how you have to be really careful, and there's a lot of practical. So how would second year labs be affected by that?
So I guess being second year instructor, I can mention that, well, we are all aware that you've only had virtual learning for the past year. And so all of our first years haven't unfortunately had any in-person learning or in-person labs. So we are aware of the fact that you're lacking the skills necessary to perform an in-person lab. So again, I think Nurusha may have mentioned this. We hope that by the end of the summer, maybe in August, if things open up and the restrictions are lifted, we have a bit of a boot camp for our program students to come in maybe like a week or so, and we teach you the skills that you need, not necessarily going through a whole 4-hour lab, but just learning, you know, how to do a separation, how to do a distillation, how to do titration, all those skills that you need, so that when you do start, you know, your second year courses, you have a little bit of experience hands-on. If that is not possible, then I mean, we're going to have to stay virtual until we do get back into the labs. But once labs do start again, we will understand that you haven't done these before. So we wouldn't just throw you in the lab and say, okay, do a 3-component separation, or, you know, do this distillation. The TAs will have to kind of maybe do refresher courses or somehow bring you up to speed before you're actually allowed to do it on your own. So we do have plans, and I think all the instructors in chemistry are invested in making sure that our students get the necessary lab skills that they need, so that you can perform, you know, in lab properly. And we mentioned PSCB 90 before, so, you know, once you're in second year, you can definitely volunteer or take that course and then get some hands-on experience on, you know, how to work with chemistry glassware and in the chemistry lab in that way.
Just to add on to what Shadi just mentioned, like with the PSCB 90, when we actually go in person into real labs, you get to actually use some of the skills that you learned in the simulation actually in person, right? So you will get to do the recrystallization, the distillation, you get to actually put together the apparatus and so on. And then as Professor Wozni mentioned, then when you take D90 or D91 in 4th year, it's even better. And if you can get a volunteer position even prior to that in some of the research faculty labs, if you have some skill set developed in the undergraduate labs, then you can apply that, right? So they're hoping for the best. We'll see. Yeah.
But how do you guys find this virtual labs? Is it any useful?
Boring.
I
Miss
actually
in-person
find
labs.
Lobster is kind of fun because Dr. One is really helpful. Like, and she's very forgiving too, which I'm sure won't be happening in in-person labs. But yeah, I feel like it is missing that like lab aspect. But I feel like the Lobster is better than last semester where we had to watch the videos. Like the Lobster is much more interactive, and like we actually, you know, we're seeing what we're doing, which is nice. And yeah, I feel like with the lab notebook, it's much more like structured, like, oh, I actually know why I'm doing this. I actually know, you know, what happens when I combine these and the equilibrium parts. And it also connects more to content right now. So like when we're talking about equilibrium and Lobster, we're also doing it during the lectures. And I know a lot of students really appreciated that. So yeah, I actually think it's a lot better than like last semester.
It's too bad that you don't have a reference point to actually compare the Lobster versus the real one.
That's true.
They won't know. So I had one student who came and asked during the officer, could you please describe as to how the labs look like?
Oh
so
no.
I pulled up a picture from my LinkedIn and I showed her this is how labs look.
Oh no.
I mean, you know, it's really, we all miss it. And it's just hard. It's hard on all of us, but hopefully we'll catch up soon. Yeah.
Also, Michael raised his hand. Is something to say, Michael?
I was gonna say, basically on my own part, I feel like the Lobsters offer a great review of the material that we're learning and all the other stuff. I feel like if we can have those going on to like in the future, they'll probably be really helpful to like review mechanisms, hybridizations, all the other like fun things. But nothing beats the in-person hand on hand, actually pouring things in the titration, which I feel bad for the first years who are here when they get that experience, but hopefully they can. All the experience, the dungeons, that is SWs, chem labs, because it's a beautiful place full of beautiful things. But yeah, especially like me as a tactile learner, I learn a lot through actually doing, not like just watching.
Yeah, Michael is in C41 right now, so he's doing organic synthesis with me and Professor Zhang, and Nahida is in C41 as well. So they're using simulations as a review material. So they have different simulations from you guys, but this is a review on the B41, B42 content. So they use it as review and then they go into lab. Unfortunately, we don't have 30 labs on Labster. So they're watching LabCo videos and then they're writing down the notes, whatever you did in first term, right? I wish I had access to Labster in the fall term. It would have been nice. But unfortunately, because our class is massive, it was around 990 students and we started off 1,020. So at that time, for a large, massive class, the license was not approved to go through, but luckily for the winter term, we had hands-on. So yeah, I'm glad that worked out for you guys.
And I think one of the other things that you're missing with hands-on, maybe something that students don't miss, but I think you learn a lot from, are the mistakes that you make when you're in person. So, when you're doing a separation, you throw out the wrong layer and there goes your product. And, oh, great, now I have to start all over. Or, you spill something when you're vacuum filtering and again, oops, there goes your product. So your yield is like non-existent. So those are the things you learn from, but you don't see that in the video simulation. So, I mean, yeah, I think, and also, yes, the labs are beautiful. So it's unfortunate we can't be in them.
This is gonna sound so bad, but during the Labster, I heated hydrogen gas by itself and it kind of blew up. I don't know if I should be saying this when our lab professors in the room, but thankfully Dr. One is very forgiving. But yeah, it definitely did teach me though, like, wow, I should not be that careless. So yeah, that's definitely Labster's way different, but it's what we have, right?
Yeah.
You should have saw. This is what me and Will did. We had B31 with Hadzovic. We had to make, what was it, chlorine gas in lab, and one of the students, so the TA fume hood is the strongest fume hood inside the class itself. So he advised to make sure you go there and to put it inside the fume hood while you're doing it, right? Because chlorine gas, is kind of poisonous. One would assume, at least. But this one of the students, he took the chlorine gas outside of the TA fume hood and just look at it to get a better look at the color, and my RTA flipped. It was a beautiful experience. Fun times.
Yeah, definitely safety is a concern once once the first years get back. But yeah, especially for inorganic labs, all the colors you get to see, and especially for organic as well, the separation funnel, you can't see that in a Labster lab. Like you have to experience it and be able to pinpoint when to stop the filtration out and all that. And especially for organic labs, I feel like it's more repetition to know when to separate, when to vacuum filtrate, and it all comes from experience. It's not something you can force in a Labster, but in C41, I really appreciate Labster and because it jogs my memory of doing mechanisms again, which is really good for B41, B42, which I haven't done in 2 years, but being able to go back and relearn that again, especially because I still think till this day, B41, B42, that textbook is probably the best textbook I've had in all like my 4 years at university. I still carry. That's the one textbook I'll probably have for the rest of my life because that explained everything for me.
Right.
It's really good to know. So Had, we are ending the breakout room soon, but I wanted to ask Professor Bosny. So we heard that you have some research in computational chemistry, and I think we actually, one of yours supervised like the students that work under you. His name is Joey Wang. He was one of my TAs, and he was talking about the third year or second year course, spectrotomy with quantum chemistry. I was wondering if you could talk more about that because I don't know, I kind of find it interesting, but I noticed in like first year, like the most we go to is like quantum mechanics and like the model of the atom. So like, could you like elaborate on like how that would look like in future years?
Well, the course is called, so that's B21, it's called Atomic Structure and Spectroscopy. And like, it's very vaguely defined. And well, it is based on quantum mechanics because to describe, like basically by the end of the course, you get to a hydrogen atom structure. So probably what you've learned in A10, like these orbitals and shapes of orbitals and energies, we actually derive in this course. But before you get there, you have to understand what quantum mechanics is, what the quantum measurement is, And like it's much more time discussing these very fundamental questions, which are like some of them we still don't know the answer. So we are really trying to figure out to make sense of it. And in order to derive, you need a lot of calculus, but that's not the point of this course. The point is really to try to figure out what it all means. And yeah, I guess different people like it different ways. So Michael and Will have gone through it. Maybe you could talk, guys. What do you think about that course?
Honestly, the approach that Professor Vosny took would made it very understandable. I know before people used to me out like how was so hard because it's so math heavy, so math focused. But just to be able to like look at the actual like, concepts and abstract ideas to get behind it was really insightful because it made me. I feel like it was better to understand that way instead of going for this pure mathematics. Because quantum mechanics in itself is kind of difficult. At least I think so. But yeah, it was a great time.
I think there are prerequisites. You definitely need calculus for sure in order to take this course.
Yeah, I believe you need first year calc to take that course. Before I took Professor Vazzi's class, I actually had to take a course downtown because I got like an exemption from Professor Simpson. So I took a kind of a mixed quantum physics with like physical science kind of thing. So they did a different approach. They did a full calculus approach to what Professor Wozny just said. So at that time, I already had taken multivariable calculus, so the calculus portion was decent for me. But yeah, with Professor Vosny's class, the labs actually helped me visualize what was going on way better than like a textbook would or any kind of literature. So I believe that would be the most helpful, I would say.
Okay, so does anyone else have any questions? I know this is a pretty small group. Nadia asked, would you recommend second year calculus as a background for B21?
Yeah, I think it's a prerequisite. Just take the prerequisite.
Yeah.
Should be fine.
Yeah.
But again, there are 3 or 4 quantum mechanics courses even here at UTSC.
Right.
And some people actually take all of them. And so I don't know if it's any different, but yeah, my goal is really not to go through calculus, but try to avoid it as much as possible.
Yeah, I think as a first year, I find calculus kind of complementing to what I'm doing right now, like in physics and stuff. I have no idea how it's going to get in upper years. I'm sure everything will get more challenging, but yeah, for sure. I find that there's a lot of math that complements the science. Also, that's all. We're going to be going back to the main room. I want to thank professors, Professor Dalili, Professor Vosny, and Professor Raja for answering questions. And we really do appreciate you guys spending your time of reading week here with us. So thank you so much. And we will be going back to the main room. I think you guys can go by yourselves if you just click. Bye. Thanks so much. Yeah, we're just waiting on them. Right, we're just waiting for everyone to come back. So in the meantime, if anyone has any questions, feel free to ask. Whether it's about reading week or courses or questions to professors, feel free to ask. Right.
Okay, welcome back to the main room, guys. If anyone else has, like, I hope everyone's breakout rooms went well. I know today we felt like we were a little short on time, and even when everyone was registering, we do have a bunch of other questions that were asked of us. So maybe we can definitely reach out to the professors afterwards and email them and see if we can pick their brains still about that. Exactly, just like Professor Sturge said. Does anyone that has to go now, we do thank you for your time. We definitely appreciate you, I guess, taking the time, especially out of reading week, to come and join us tonight. We hope you did gain some sort of insight, whether you wanted to come just to hang out and get to talk to some people, or if you had particular questions about program selections, which are coming up in March. We're glad you could join us anyways. Thank you to everyone. Anyone that can stay, though, please do stay in the main room, and then we are going to start with the games or the next session.
Yep. And once again, I just want a gentle reminder that if you are like trying to cram everything for reading week, please do take breaks, drink water, eat healthy food, and just don't be too hard on yourself. I know school can be really stressful, even if you're a first year, second year, even a professor. Just pay attention to your mental health, and yes, do study, but just know that like after all, like the whole thing, you want your mental well-being to be at its best, right? So do take breaks, do take care of yourself, and yeah, we really do hope this time here has given you guys a chance to relax. So yeah.
So with that, we are going to move on to games. Do any of you have any suggestions? We do have Among Us, Jackbox, Codenames. Codenames is my personal favorite.
Even if you don't know how to play Codenames, I'll teach you. It's like super fun.
Is anyone against it? Because the good thing about Codenames is that we can actually play it with a big group, whereas a lot of the other games are a maximum of 10.
We can make a pool though, or a poll. So we have Scribbly.io. That's a really fun one.
That one is so hard to pronounce.
I know.
Describe what Codenames is?
Sure. I'll explain it. So Codenames is basically this online game. So we give you a link and then you click the link. And then it's basically, so there's two teams. There's a red team and there's a blue team. And then there's word master, a code master in each team. And they basically give the hints. So there's this giant display of words. And if you flip, and then only the code masters can know what those like words are. So I feel like I'm doing an awful job at explaining it. So all the team players will see the color as beige, but the code masters will actually see the color. So the code master will see blue, red, and then the code master needs to give hints to their team to make sure that they guess the word that is on their color. So say there's a word and it's car and it's red, and I'm the game master. So to the red team, I would be like one word, vehicle. And then to everyone else, they'll see beige cards and one of the cards will be car. And that'll be the red card, but only I can see that. And then if they say it's car, then the red team gets a point. If they guess the blue team, then the blue team gets a point. And I feel like I described that so badly. So if anyone else has an alternative explanation, feel free.
It might also be one of those games that like is easier when you play through it. I think I just sent a link through the chat if everyone that's interested wants to click through that. It should be right, but someone tells me if it doesn't work.
It works.
Okay. So you should be able just to be asked for your nickname and then you can join the game. And then we will be splitting up the two teams. The gist of it is kind of like you're given a word, you have to describe that word and as many other words in. Yeah, this is harder. Can you show? I get what you're saying. That's your turn. When you see the board, maybe we can explain it then, because it'll be easier when we have like example words. So we're gonna stop now.
We'll have a try